Hello everybody, welcome back to this training on natural language processing. Uh, in the previous video, we looked at some of the techniques for doing exploratory data analysis with text data. In particular, we looked at how can we construct a bag of words representation from the document term matrix, which is the most fundamental building block of text data representation. In this video, we will look at some of the more intricate things like how we can look at not just words in isolation, but different combination of words or phrases. And in the context of text analytics or in the context of natural language processing, we call these as Ngrams. The combination of words, we call them as Ngrams. So uh, Ngrams is actually a generic term. If we are looking at a combination of two words appearing together, then we call it 2 grams. If we are looking at phrases of 3 words, we call them 3 grams, so on and so forth. The generic term that is used in the literature is called Engrams. So, word tokenization as an activity need not always mean, that we have to split up uh, sentences or paragraphs into words. Even though we started off with that concept, we said that the most granular yet meaningful component of any paragraph or any sentence is the word. Now, if we go a notch higher than that, not at the most granular level, then we can also think of that every pair of words which appear consecutively, they are also building blocks of a sentence or a paragraph. And similarly, we can also look at phrases or 3 words appearing consecutive to each other. So that is the concept of Ngram tokenization. So instead of looking at just singleton words, we will also look at 2 words which occur consecutive to each other, or 3 words which occur consecutive to each other, and that is very helpful because understanding language is not the simplest thing to do. And in fact, it's far more complicated than understanding insights from numeric data or from categorical data, because numeric data or categorical data, it's by the very nature of it, it's structured. If it is a numeric data, there is an element of monotonicity to it. You know what is low, what is high. You also know how high is high enough, and some of the statistics like central tendency, standard deviation. These are very straightforward to define, but language is far more complicated, right? And that being the case, looking at singleton words will not always be helpful. For example, if I want to say that something is bad, I might say that it's bad, or I might say it's not good. Or, for example, uh, if I have to say that uh, I'm talking about any particular product, right? And if I have to say that this product is very helpful, I can say that this product is very helpful, and then it explains my perception about that product. But instead of saying that the product is very helpful, I can also say that the product is great. So I can express myself in different ways. And Ngrams helps us in dealing with these intrinsic complexities which lie with languages. And also, citing another example from the data that we are using for most of the hands-on exercises or most of the hands-on illustrations, it is the Amazon product review data. We have 1,000 product reviews made public by Amazon, and then we have, for each of the reviews, we have the sentiment polarity, that whether it's talking positively about the product or it's talking negatively about the product. So in this kind of a data, if you construct some bigrams with one of the words being you know name of a product. So for example, if you look at all 2 grams or all bigrams where the word uh, mobile is present, right, then you can immediately understand that whatever representation you get is actually about the specific product mobile phone, because there can be reviews about multiple products as well. So these intrinsic challenges of working with text data becomes a little easier to handle if you look at not just words in isolation, but also their combination with other words. Okay, so but all these comes with a price tag, with a cost, because remember, when we talked about the document term matrix, one of the challenges of the document term matrix that we discussed was the high dimension, and the high dimension was being driven by the incredibly large number of columns that we get in the document term matrix, because typically we would have many unique words in a collection of text data. And if you recall from the first hands-on session, that in the Amazon review data set, product review data set, with just 1,000 reviews, and these were not very lengthy reviews, so these were just a single line or a couple of lines mentioned about some of the products. Even after we stripped off the stop words, we did the basic cleansing. With just 1,000 reviews, we had around 1,400 unique words. That's huge. So and that was using singleton words, right? We were not even looking at bigrams or more linear phrases. So if you look at bigrams, and if you look at 3 grams, or if you look at more lengthy phrases, what happens is every single bigram that you look at, it actually adds one additional column to your already large document term matrix, and adds to your challenges. So it further increases the dimension of the document term matrix. So while we are saying that yes, looking at words in combination help us deal with some of the inherent challenges of working with text data, but then it makes the already existing problem of dimensionality uh, even aggravated. So there must be some strategy to look at what kind of bigrams or what kind of ngrams we want to consider from the text data. So we'll look at them as we move ahead. So so this is a very quick illustration. So I'm sure you remember this example from the previous video. So this was that handcrafted example about the lunch and the dinner, one of them being great and the other one being terrible, right? So the first sentence and the second sentence, they actually say the same thing. They say that the lunch was terrible, but the dinner was great, and but they are phrased differently. And the third sentence semantically has the opposite meaning. It says that the dinner was terrible, but the lunch in fact was great. So in this sentence, in the 3 sentences, if you just look at the document term matrix and you look at the bag of words representation using the term frequencies, one of the things that you will see is that even though the term frequency of or the document term matrix will give you that which are the amongst the unique terms, in this case we have 6 of them, uh, which are underlined out here. After obviously after removing the stop words and all that, it will give you that what are the different words which are present in different sentences. But let's say for sentence 1, it will give you lunch served today, dinner terrible great, but it's not so straightforward to understand whether the lunch is great or the dinner is terrible, and so on and so forth. So instead of looking at just words in isolation, if you look at, let's say, some um, combination of words or some bigrams, then it gives some more additional information. So for example, if you look at this particular bigram served today, it immediately gives you the information that that whatever is being talked about is actually about an event which happened today. So served today. Then uh, let's say this is maybe an extreme example, but let's say you are looking at this trigram or a 3 gram, dinner was great, okay, it immediately tells you that, you know, and then what will happen is that this phrase dinner was great, it will come with a count of 1 in sentence 1, but it will not be there in sentence 2 or in sentence 3, right? So what will happen is that it will, at least for sentence 1, it will help you understand that it is the dinner which was great that is being talked about. Similarly, if you look at the trigram lunch was terrible, so it will again help you understand that it was the lunch which was bad and the dinner which was good. So these kind of meanings, which are not always easy to understand from singleton words, can be it can be a little bit easier to understand them if you consider combination of words, right? So we'll move ahead and see that how do we deal with the problem of Ngrams. And why I'm saying it's the problem, because I mean, the more Ngrams you consider, the more lengthy phrases you consider, the more you add to the dimension of the document term matrix. So obviously it is neither possible or nor pragmatic to consider all 2 grams, all 3 grams, all Ngrams of the data that you are using. Because if you do that, then essentially what happens is you are basically representing your entire text through all the columns of the DTM. It becomes almost a full enumeration of your entire text, and and the DTM becomes of gigantic dimension. So the core problem here is to find out that yes, bigrams are important, but then what should be the strategy to select what is the right bigrams to consider, and what are the ones that we should not consider. Now, having said this, just to set expectations, there is no fixed algorithm which will do this uniformly for all problems that you're handling. This is very much problem specific, and you got to learn from the data itself. Look at the uh, data and find out what kind of bigrams will be important here. And often the domain knowledge about the data also helps, that what is this data about, what kind of text, what is the context of the text data that you are dealing with. Is it a product review data? If it is a product review data, then what kind of products does it cover? Does it cover all products, or in any particular kind of product, like fashion items, or electronics items, so on and so forth? Or are you dealing with customer survey data, where customers are giving feedback about different about some kind of service? So obviously the data that you are handling, you will have at a macro level some idea about the source from where the data has generated, what is the context, what is the domain, and it is that context knowledge, that domain knowledge, that will help you decide that what are the kind of bigrams that should be considered at a heuristic level. But there are some other approaches as well, but then to start off with, domain knowledge does help a lot. So for example, in this case, since we know that this is a data of Amazon product review, and we have seen in one of the previous visualizations that it has reviews about most of the electronic products, so we can maybe look at all bigrams where the term mobile or the term laptop is present. So that can be one strategy. Okay. The other important thing, and that becomes important in most cases, I stress on the word most. It's not uniform across all use cases, but then it's quite handy to know that it's, you know, a very important component of text data is adjective, because it actually describes a sentiment, it describes a lot of things about what is being talked about in the text. So often, it is useful to find out, when you do the text visualization using a word cloud, or using any kind of text visualization that we have seen, and we'll do the hands-on of them as well later on. It's a good idea to find out, which are the adjectives, and then use some of those prominent adjectives in constructing some of the bigrams. So negation of an adjective is actually very important to consider, because If it is negation of a positive adjective, then it actually carries a negative connotation. Whereas if it is the negation of a negative adjective, then example not bad, then the subsequent the connotation comes out to be positive. So uh, almost always when you're dealing with text data, you should and you must consider the uh, bigrams comprising of the adjectives. In one of the later videos, we will talk about how to identify different parts of speeches from the text. What is a noun, what is a verb, what is an adjective, how to find out the parts of speeches from a text. And once you find them out, it will become more easier to find out that what are the more predominant adjectives in the data that you are handling, and for which of them you should consider the negation in constructing the bigrams. So that is another strategy that we can follow. So moving on, there's another strategy which another approach that is frequently followed in determining that what kind of bigrams or what kind of engrams phrases can be important, and that is called the context window analysis. Now, before going into how it helps in bigram selection, let us understand what a context window analysis is. It's very intuitive and very straightforward. So context window analysis is actually when we are saying that from the entire text data, I'm basically specifying a particular word or a particular token, and then I am defining a neighborhood around that token. And the neighborhood can be, let's say I define a word and I say that every every word which is 5 words to the left of this pivotal word and 5 words to the right of this pivotal word should be considered. And this should be done wherever we see that pivotal word in the text data. So essentially, I am drawing a sample from my text data, but it is not a random sample, it is a judgmental sample. And how am I drawing it? Let's say for the product review data example, I say that wherever I see the word mobile, I want to look at all words five within which are within 5 spaces to the left of the word mobile and within 5 spaces to the right of the word mobile for all occurrences of the word mobile in the text data. So what will it, so it obviously draws a sample out of my text data, not a random sample, but a contextual sample. And what is that sample tell, what does that sample tell me? That sample tells me that wherever the word mobile has appeared in the data, what is the context in which it has appeared? What are the other words which have occurred in the neighborhood of the word mobile? And this fact that I am specifying 5 words to the left of the word mobile and 5 words to the right of the word mobile, so this neighborhood is called the context window. More often than not, we deal with symmetric context windows. So number of words to the left of the pivotal word and number of words to the right of the pivotal word is typically taken as same, but there is no hard and fast rule that you have to do that. You can take it, you can have an asymmetric context window as well, where you can specify that I want to go 5 words to the left of the pivotal word, but when it comes to the right side, I want to go only 3 words to the right side. So that is also possible. But uh, whether or not it's a symmetric or asymmetric context window that you are using, that will not make a lot of difference in most cases to your analysis. What will actually make a difference is what is the length of the context window that you are selecting. Is it 2 words to the left, is it 3 words to the left, or 4 words to the left, and obviously the similar length to the right. So length of the context window often makes the difference, because that actually to a large extent determines the size of the sample that you are drawing from your entire text data. So let us look at a very trivial illustration to understand how this thing works. So I have 3 sentences here, okay, and I think you have seen these sentences somewhere before in one of the previous videos as well. So the first sentence says this is a natural language processing training. The second sentence says it was real hard work putting the training material together. And the third sentence says hope our delegates find this training beneficial. Now here I have three sentences, and let's say I select a pivotal word to be training, and I select my context window to be 3. So what I want to do is then wherever the word training appears, I want to go 3 words to the left of that and 3 words to the right of that and chunk out all those words into my sample. Essentially I'm doing a sampling out here. So let us look at the first sentence. So the word training appears right at the end, and so I go 3 words to the right of that, to the left of that, which gives me the words natural language processing. And this is the last word of the sentence, so there is nothing to the right of it, so nothing to chunk from the right. So I go to the next sentence. Here for training, the if I go 3 words to the right, I'm getting the words. What are the words I'm getting? Work, putting, the. By the way, I'm assuming for the sake of illustration, I am not stripped of the stop words here. So, but in real life problem, you will basically strip off the stop words before you do this. But for the sake of illustration, these sentences are, the full sentences, the grammatically, aesthetically correct sentences. Okay. So for the second sentence, when I look at the word training, 3 words to the left of it are work, putting, the. So I get work, putting, the. And then 3 words to the right of the word training. Actually, there are just 2 more. Then the sentence ends, material and together. And then when I look at the word training in the third sentence, in the left hand side I get delegates find this, and in the right hand side I get just one word beneficial because the sentence ends. So this gives me a sample out of this entire text data, a judgmental sample defined as all words which are in the neighborhood of the word training. And what kind of neighborhood? 3 words to the left, 3 words to the right. So once I have done that, I can now imagine that this is a collection of words about not just natural language processing training but about all sorts of data science trainings, right? Uh, if I if I split out if I strip out the words in the neighborhood of training, in this case I understand that what is the training all about. Is it about NLP? Is it about something else? So I find out some context about the pivotal word training, right? And then I also find out that I'm talking about the training material, and so I'm talking about the whenever I'm talking about the training, I'm talking about the training material as well. I'm also talking about the delegates who will perhaps be uh, taking this training or attending this training. So that is the kind of context that I get. Now, so context window analysis can help in effective bigram and Ngram selection. So these words, I know these words appear in the vicinity of the word training in my entire data, and how close they are to the word training, I know that as well because I have specified the context window. So these words, they are within uh, a distance of 3 words either to the left or the right of the word training. So I can define bigrams or trigrams using that. So for example, instead of taking context window 3, if I would have taken a context window of 2, I would have very easily been able to define some of the bigrams here, right? So for example, here training material, I would have been able to find the bigram training material. I would have been able to find the bigram training beneficial. I would have been able to find a bigram processing training. Obviously that wouldn't have been a very meaningful bigram, but I could have been able to identify that. So obviously, what context window analysis helps me do is instead of looking at all bigrams or all Ngrams or all trigrams, it helps me understand that what are the bigrams which can be useful. Now, the other question which remains is that, how do we select on the pivotal word? So obviously that answer will come from two things. One is the exploratory data analysis that we have done, where we can look at the frequency of different words present, what are the most important words present, and also from the domain knowledge or the context knowledge about the data that I am dealing with. So what is the source of this data? What kind of scenario has generated this data? Is it a product review data? Is it customer satisfaction survey data? So all these things will help me determine the pivotal word. Okay. Now, in this case, if you see, the example that we were seeing, since we looked at, since these were short sentences and we had only three sentences, by looking at a context window of length 3, we actually, even though we got a sample, but we got a very big sample from the entire data. So you almost, got all the words of the data. You can think of it as a 70% or 80% sample of the data. So, but in reality that will not happen, because in reality you will not have three sentences. You'll have a lot more sentences and a lot of diversity with respect to words as well. So not all words will be present in all sentences. Some of the words will be present in some of the sentences, and in those scenario, uh, you can you can use a context window of 3, but 3 obviously was a very big context window in this case. So I think one of the things that you should always do is, whenever you are thinking about context window, before deciding on that, you should look at a distribution of how lengthy the sentences are. What is the distribution of the length of the sentences? If you see that most sentences are of the length, around 8 to 10, just giving an example, then perhaps a context window of 3 or 4 is meaningful. But if you look at, that most sentences are of the length 5 or 6 or 4, as we saw in case of the product review data, because these were one line, two line reviews, there 3 is perhaps too big a context window, because you know that every sentence is, 5, or most of the sentences are 5, 6, 7 words. So choice of the context window is judgmental, but you can be guided by, the size of the data, the length of the sentences, so on and so forth. And choice of the pivotal word will come from your domain knowledge, the knowledge about the context from where the data has originated, and also about the exploratory data analysis that we have done, from where we can find out what are the important words. Lastly, if I look again, come back to this example of the lunch and the dinner being great and terrible, here if I use, let's say, terrible as a pivotal word, and then I define certain neighborhoods across the word terrible, or if I define great as the pivotal word and then I define certain neighborhood across the word great, it also helps me understand, right, that whether the lunch was great or the dinner was great, which one was great and which one was terrible. It helps me understand that. Without a context window analysis, that would not be very straightforward to understand, given the complexity of the sentences here. So that brings us to the end of the exploratory data analysis part for text data. So we looked at how text data can be represented in the form of a bag of words model. We looked at the term frequency representation. We looked at how some of the visualizations can be worked out, and what kind of insights can be drawn from them. We looked at the concepts of Ngrams, and then we realized that how often words in isolation doesn't give the insight which a pair of words or a phrase of three words can give. And then we also looked at the challenge of using bigrams or Ngrams, because it will disproportionately increase the dimension of the document term matrix. So we looked at discussed some strategies of how the bigrams can be selected. So instead of looking at all bigrams, you can look at only the meaningful ones, and how you can do a context window analysis using a pivotal word and the neighborhood around the pivotal word. And we also discussed that what can be some of the heuristic ways to determine what pivotal words to select and what should be the right neighborhood of the pivotal word in this case. So in the next video, what we will do is we will do a hands-on of the exploratory data analysis with R. We'll use R, and once we are done with that, we will actually reach a milestone in the sense that uh, we can then say that we have been able to uh, read text data, represent it in a structured format in the form of a document term matrix, do some basic dimension reduction, looked at some of the exploratory analysis like what are the important words, what are the bigrams, etc. And then uh, actually tested out all those concepts uh, hands-on using R, and that will be the milestone after which we should be able to start some real analysis using the text data. So far whatever we have been doing is the EDA or the exploratory data analysis part. The crux of the analysis we can only start after we are done with this phase. So hope you enjoyed this video and hope you are enjoying the course so far. So stay tuned. We'll have a subsequent series of videos, uh, obviously starting off with the hands-on and then more complicated things in natural language processing. Thank you for watching. Thank you for being with us.